For decades, aircraft carriers have remained the ultimate measure of naval power. They are not just warships. They are moving air bases, political statements, and strategic tools that can reshape entire regions without firing a single shot. And no country has mastered this instrument of power like the United States. Today, nearly 1/4 of all aircraft carriers in the world belong to the U.S. Navy. Even more striking, the total deck space of American carriers is more than double that of every other nation combined. This gap is not accidental. It is the result of nearly a century of continuous carrier warfare experience, industrial scale, and technological iteration. At the center of this dominance stands a ship that represents a clear break from the past, the USS Gerald R. Ford. Costing an estimated $17 billion, it is not simply a replacement for older carriers. It is the opening move in a new generation of naval warfare. The Gerald Ford class is the first new American aircraft carrier design in more than 4 decades. 10 ships are planned. 1 is already active. 2 more are under construction. And before it ever entered service, the program forced the U.S. Navy to pause or cancel thousands of other projects to concentrate resources on making this carrier work. With a displacement of roughly 100,000 tons, the USS Gerald R. Ford is among the largest warships ever built. But size alone is not what makes it different. What truly sets it apart is the sheer number of new systems integrated into the ship. 23 major new technologies were introduced, an unprecedented leap compared to previous carrier generations. At its core, the ship is powered by 2 A-1B nuclear reactors. These reactors generate far more electrical power than their predecessors, enough to support future systems that have not even been fully deployed yet. The carrier can operate for up to 25 years without refueling, while maintaining speeds of around 30 knots. This gives it global reach, sustained presence, and unmatched operational endurance. But power alone means nothing without aircraft. At any given time, the USS Gerald R. Ford can operate up to 75 aircraft, including fighters, electronic warfare platforms, airborne early warning aircraft, helicopters, and unmanned systems. In surge conditions, that number can increase even further. Among these aircraft is the F-35C Lightning II, the U.S. Navy's 5th-generation stealth fighter. It represents one of the most expensive weapons development programs in history, but it also gives carrier air wings capabilities that older jets simply cannot match. Advanced sensors, stealth, data fusion, and long-range precision strike turn the carrier into a floating command node rather than just a launch platform. And the ship is already designed with the future in mind. When 6th-generation naval fighters eventually enter service, the Gerald Ford class will not need fundamental redesigns to support them. Its systems were built with that transition in mind. One of the most visible changes is the way aircraft are launched and recovered. The USS Gerald R. Ford replaces traditional steam catapults with an electromagnetic aircraft launch system. This system allows more precise control over launch forces, reducing stress on aircraft and enabling a wider variety of platforms to operate from the deck. Paired with an advanced arresting gear system, the carrier is designed for thousands of launches and recoveries with improved efficiency. These systems promise higher sortie rates, faster deck cycles, and lower long-term maintenance demands. While early operational challenges have attracted attention, the underlying shift represents a fundamental change in how carrier aviation functions. However, the United States is not alone in pursuing next-generation carriers. France, a long-standing naval aviation power, is developing its own future carrier under the PANG program. Intended to replace the Charles de Gaulle, this new carrier will be nuclear-powered and significantly larger, displacing roughly 75,000 tons. 2 K-22 reactors will provide propulsion and electrical power, allowing near unlimited range and sustained operations. The PANG is designed to operate electromagnetic catapults and arresting systems similar in concept to those used by the United States. Initially, it will operate the Rafale M, before transitioning to a future 6th-generation fighter developed jointly with Germany and Spain. Unmanned systems will also play a central role, reflecting the broader shift toward manned-unmanned teaming. With a projected crew of over 2,000 sailors and an estimated cost of around $5 billion, the Peng represents Europe's most ambitious carrier project in decades. China, meanwhile, has moved quickly. Its third aircraft carrier, the Fujian, marks a major step forward in Chinese naval aviation. Launched in 2022, it abandons the ski jump design of earlier carriers in favor of electromagnetic launch systems. While it uses conventional propulsion rather than nuclear power, the Fujian's displacement of roughly 80,000 tons places it closer to American supercarriers than any previous Chinese design. Details remain limited, but the Fujian is expected to operate a diverse mix of aircraft, including advanced fighters, early warning platforms, and potentially unmanned systems. Its construction alone signals China's growing industrial and technological confidence in carrier development. South Korea is also entering the carrier arena for the first time. The CVX program represents a major evolution of the Republic of Korea Navy, which has spent decades transitioning into a true blue water force. Based on experience gained from amphibious assault ships, the CVX will feature an axial flight deck and operate F-35B short takeoff and vertical landing fighters. Displacing around 45,000 tons and costing an estimated $1.8 billion, the CVX will not rival American supercarriers in size, but it reflects South Korea's strategic intent to project power beyond coastal waters and integrate air power directly into naval operations. Taken together, these programs show that the aircraft carrier is far from obsolete. Instead, it is evolving. Carriers are becoming more networked, more electrically powerful, more dependent on unmanned systems, and more deeply integrated into joint and allied operations. Yet when analysts compare capabilities on paper, one conclusion remains consistent. The Gerald Ford class represents the highest concentration of naval aviation power currently afloat. Its size, power generation, aircraft capacity, and growth potential place it ahead of any competitor entering service in the near future. The real test, however, will not be theoretical comparisons. It will be how these ships operate in contested environments, how well they integrate new technologies, and how effectively they adapt to rapidly changing threats. As the 2030s approach, the world's oceans are becoming more crowded with advanced carriers. The balance of naval power is shifting, but the outcome is not predetermined. What is clear is that the era of the aircraft carrier is not ending. It is entering its next phase. And for now, that future is being shaped from the deck of the USS Gerald R. Ford.